Okay, so I'm just gonna go through part C here, just because we rushed it at the end of class. So just to review, we know that this boat, ship A, is going this way. That means X is getting smaller. So my rate at which my X length is changing is going to be negative 15 kilometers per hour. And this ship B is moving away from the lighthouse. That means Y will be getting bigger. So dy dt is positive 10 kilometers per hour. And we know that X is 4 and Y is 3. And from part A and a Pythagorean triple, we know that this hypotenuse length, which I'm going to use as H, is 5. Now, we don't actually need H for part C. We're just going to use X and Y and theta. So I defined my variables. Okay, what am I looking for? I'm looking for d theta dt. That's the rate at which theta is changing in radians per hour when X equals 4 and Y equals 3. So I need to come up with an equation that relates how X, Y, and theta compare. And that will be using the tangent function. So tangent of theta equals Y over X, opposite over adjacent. Now I'm going to do step 4, which is to derive. So secant squared theta times my derivative coefficient. So I just derived a theta, so it's d theta dt. Remember, the numerator is the variable I just derived, and then the denominator is my independent variable for the situation. And then this is going to need a quotient rule. So that's going to be my F, and that's my G. So G times F prime minus F times G prime all over G squared. Okay, I'm going to go ahead and start by just plugging in what I do know already. So the secant squared theta d theta dt equals, I know my X is 4 times 1 times dy dt, which is 10, minus 3 times negative 15 all over 4 squared. So that's going to simplify to, that's 40 plus 45. So secant squared theta d theta dt equals 85 over 16. Now the problem here is that I still have 2 unknowns. I don't know what d theta dt is. That's what I'm looking for in the question. And I don't know what theta is. Now, I don't need theta to figure out what the secant of theta is. It all has to do with our right triangle trig. So if I have this triangle right here, where this is 4, 3, 5, and this is my theta, then I know that the sine of theta, this is just a review where I don't need most of this stuff, is opposite over hypotenuse, so that's 3/5. I know that the cosine of theta is 4/5, and the tangent of theta is 3/4, opposite over adjacent. Okay, now if I'm trying to find the secant of theta, which remember this secant squared theta is another way of writing this, the secant of theta squared. Okay, secant of theta is 1 over cosine of theta. So if I know that my cosine of theta is 4/5, then the secant of theta is going to be 1 over 4/5, which when I flip and multiply, the secant of theta is 5/4. So really this is 5/4 squared d theta dt equals the 85 over 16. So 25 over 16 d theta dt equals 85 over 16. Multiply by the reciprocal to get rid of that fraction, so d theta dt is alone. I'm going to do that again over here. Those 16s cancel. Then I can reduce by 5, and I have d theta dt equals 17/5 radians per hour. Hope that helps. Good work.